Hello class, today we are going to be carrying out column chromatography, and the purpose of today's experiment, as I already told you, is to separate a mixture of methylene blue and fluorescein. Okay, now methylene blue is less polar than fluorescein, so fluorescein is more polar than methylene blue. Now, like I already told you, column chromatography takes advantage of the fact that two compounds or two or more compounds that are about to be separated have different polarities. So separation is achieved because of the difference of polarities between the different components. Now, because methylene blue is less polar than fluorescein, methylene blue will travel faster than fluorescein on the chromatographic stationary phase, thereby separating itself from fluorescein. Now what I have, as you can see here, is a column. I have a column, and this column has a frit, a glass frit, and this glass frit prevents the stationary phase from falling out of the column. Now if I didn't have this glass frit, then one thing I could do is I could just simply put some glass wool. I could put some glass wool, and that will ensure that the stationary phase is secured in the column. Now the stationary phase that we have today is alumina. And alumina is a polar stationary phase. It has, if you look at the structure, it's aluminum oxide. Okay? And so it's able to hydrogen bond with different compounds that have hydrogen bonding. So what I have in my hand now is I've put some alumina in a beaker, and so I'm going to have to load the column. Okay? No, I'm going to have to pack the column. So I'm going to pack the column with the stationary phase. Okay? Now the stationary phase is a mixture of alumina and the less polar solvent that I'm going to be using for this separation. Now I have two separate solvents I'm going to be using. I'm going to be using water, and I'm going to be using ethanol. Now ethanol, as you already know, is less polar than water, and so I'm going to mix this stationary phase with some of the less polar solvent, which is ethanol. Okay, and so I'm going to form a slurry, and basically what I'm going to do is I'm going to mix it up like this. Okay, I'm going to mix it up. See, I'm going to mix it. I'm going to add some more solvent. Okay, I'm going to add some more solvent and mix it up. Okay, and then the next thing is that I'm now going to begin to pack the column. Okay, I'm going to begin to pack the column, and the way I'm going to pack the column is by simply pouring it this way. And of course, you're going to put some here, something to collect the solvent. See, so we are packing the column now. We are packing the column. Okay, we are packing the column with the less polar solvent. The less polar solvent we're dealing with here is ethanol. Now we're going to be using two solvents to achieve this separation. We're going to be using two solvents to achieve the separation. We're going to be using ethanol, and we're going to be using water. Okay, because ethanol is less polar than water, we're going to mix the stationary phase with the ethanol first. Okay, and then we're going to use that to pack the column. Okay, we're going to use that to pack the column. Now, to ensure that the column is properly packed, you want to use air. Okay, so what I have here is air. So I'm going to use the air to force. I'm going to use the air to force the solvent through the stationary phase, or So I'm going to use the air to force the mobile phase or the solvent through the stationary phase. And in the process, what I'm doing is that I'm packing the column. I'm making sure that the column is tight, it's airtight. Okay, you don't want air pockets in there, because if you have air pockets in there, it's going to prevent the good separation. See? So we're going to use this to pack the column. So we're going to add some more, because you can see you really want to pack the column to about 2/3 the height of the column. So we're going to add some more of the of the stationary phase, and then add some of the mobile phase. Remember, in any chromatography technique, you should have a stationary phase and a mobile phase. So we mix the stationary phase, which is alumina, and the mobile phase, in this case, which is ethanol, to create a slurry. And with this slurry, we can now pack the column. So we now pack the column. We add some more solvent to make sure we have a nice slurry, and that the stationary phase can easily flow through this like this. So we pack. See? So we're using this to pack the column, the air to pack the column. And then we're going to add the last bit of the stationary phase and the mobile phase in a nice slurry. We'll mix it real nice, and then we're going to pour it like that. See, we're going to pour it in like that. Okay, I'm going to pour it in there. Then we're going to use air to force it down. Okay? We're going to use air to force it down. You want to make sure that the column is packed properly. You don't want any air pockets. Okay? You don't want channels forming, as you will learn later on. Now you can see that the column has been properly packed. It has been properly packed. Okay? So you're going to force the solvent out until it's about maybe half an inch from the surface of the stationary phase. It's at this point that you're now going to you're going to load the column. So that's the next thing what we want to do now. We're going to load the column by adding the mixture. This is the mixture. We're going to load the column with the mixture. See? We're going to load the column with the mixture. So you can see now that the column has been packed. Already, you can see that separation is already occurring. Okay? The methylene blue, which is less polar, is traveling faster than the fluorescein. Okay? So the next thing you want to make sure is you add a little bit of solvent, because you don't want it to dry up. That's something you should always ensure that it doesn't dry up. Okay, so now the column has been packed, and you can already see that now we have loaded this column with the sample. So not only have we packed the column, but we have also loaded the column with the sample. Okay, so the first thing you have to remember is we pack the column with the stationary face and the mobile face, and then the next thing is to load the column with a mixture of the mixture of the compounds that you're trying to separate. We have methylene blue here, and we have fluorescein. Okay. So you can see that the separation is already occurring, because methylene blue is less polar than fluorescein. The methylene blue clings less tightly to the stationary phase and travels faster, while the fluorescein, being more polar, you see, clings more tightly to the stationary phase and travels slower. So you can see that separation is achieved because of the selective adsorption and desorption of the components as they travel down the stationary phase. Notice that this here, of course, is the methylene blue, which is less polar, while this is the fluorescein, which is more polar. Notice that the less polar component travels faster, while the more polar component travels slower. Like I told you at the beginning of this talk, separation is achieved because of the difference in polarities. So we can use the difference in polarities to be able to determine, how the separation will occur. Now, if I leave this separation to continue under the force of gravity, it's going to take forever. So what I'm going to do is I'm going to employ some air to force this down. So as we continue to elute, the compound, the less polar compound, you can see that the less polar compound is coming out now. You can see the yellow. You can see you can see the light blue coming out. And then we go to the next tube. You can see the less polar methylene blue coming out now. You see the less polar. Methylene blue coming out. You can see it coming out, right? You can see the less polar methylene blue coming out. So we continue to do that until we have all, but there's something you have to remember. Make sure that this solvent does not fall below the level of the stationary phase, because if that will happen, if this whole column were to dry up, in other words, if we drain out all the solvent, what will happen is that will lead to what we call channeling, and channeling will just create channels in between the column, and as a result, when you pour your sample, your mixture, it's just going to go through the channels without achieving any separation. And so that's something you have to remember. You don't allow the level of the mobile phase to go below the level of the stationary phase. Okay, so we're just going to add some more solvent. My solvent, like as you already know, is ethanol. So we're going to add some more solvent, and then we're going to keep discharge. We're going to keep eluting the. We're going to keep eluting the compound. Okay, so we keep going. Okay. You can see that the less polar methylene blue is coming out now. Okay. You can see that the less polar methylene blue is coming out. You can see it. See? You can see the less polar methylene blue coming out now. Okay? And so, you're just going to have to continue to elute it. And then go to the next tube. Get the next tube here. And then you're going to keep eluting. So you can see that we are almost done eluting the methylene blue. You can see that there is no, all the methylene blue is almost gone. Most of it is almost, everything's almost gone. So you just have to keep eluting. See, until we have succeeded in removing all the methylene blue. Okay. So once this tube is filled, you go to the next tube. Okay. And keep eluting. So as you can see, we have succeeded in separating out the methylene blue. The methylene blue has been separated out nicely. Okay, so the next thing we're going to do is we're going to have to get out the fluorescein. But you can see that the fluorescein is stuck at the beginning of the column here. It's stuck on top of the column. And the reason why is because fluorescein is really much more polar than methylene blue, right? And so it's clinging really tightly to the stationary phase, to the polar stationary phase. Remember, like dissolves like. Fluorescein being more polar will be attracted to a more polar stationary phase. And that is why it is stuck on the stationary phase. Now, to get the fluorescein off the stationary phase, what you need is a more polar solvent. You have to increase the polarity of the solvent. And so what we're going to do is we're going to have to add some water. So we're going to add water. So water is more polar than ethanol. So we're going to increase the polarity of the solvent to get the fluorescein off the column. See, we're going to increase the polarity of the solvent to get the fluorescein off the column. And you can see what's going on here. And then we're going to now begin to elute the column. Notice that once I added water, you can see that it dissolved the fluorescein even much better. Okay, so now we're going to begin to add, we're now going to begin to elute the fluorescein of the column. Okay, so we have increased the polarity of the solvent, and after increasing the polarity of the solvent, I want you to see something here. I want you to see that, you see, can you see that? Can you see that the fluorescein has started traveling down the column? Okay, And basically that's what is happening because we are using a more polar solvent. The more polar solvent is going to dissolve the fluorescein and cause it to travel faster. So if you want to increase the retention time, right, you use a less polar solvent. If you want to decrease the retention time, then you need a more polar solvent, and that's what we're doing right here. So we have to keep eluting until we get the fluorescein off the column. So let's keep doing that, and I'll show you what happens shortly. So you can see now that the fluorescein has traveled even farther than where it was before, and that's because we have increased the polarity of the solvent. Okay, now to get the fluorescein off the column, we have to keep eluting with water. So you can see that the fluorescein is now being eluted with a more polar solvent, which is water. Water is a more polar solvent, okay, so it's able to elute or mix better with the fluorescein and thereby elute it. Can you see the fluorescein coming out? And so we continue to elute the fluorescein with the water. So we keep doing this until all the fluorescein has gotten off. Of course, we're going to have some stains, but that's still okay. The majority of the fluorescein will have gotten out at the end of the experiment. So as you can see, we are almost done with the whole separation. You can see the methylene blue on the right. You can see the fluorescein to the left. Okay, you can see that most of the methylene blue is actually off the column, very, very little. Whatever is left is just a stain on the column, which will not get off. So it's almost done, and so all I need to do is just to get rid of the remaining solvent. And once we get rid of the remaining solvent, we should be ready to unpack the column. Okay, so the next thing I'm going to start doing is I'm now going to begin to continue to elute until I get rid of all the fluorescein. So as you can see, we are just almost done with the final step of the elution of the fluorescein, and that will conclude the separation of methylene blue on my right and fluorescein on my left from one another using column chromatography. And as you can see, the only reason why separation was made possible is because of the difference in polarities. Methylene blue, which is less polar, travels faster and so has a smaller retention time, while fluorescein, which is more polar, travels slower and has a longer retention time. So separation is achievable using column chromatography because of the difference in polarities, as you can see. And so we're just going to conclude that. We're going to elute what is left, and then I'm going to show you how to unpack the column, and we should be done. I'm going to show you how to unpack the column shortly, and we should be all done. So to unpack the column, all you need to do is you need to drain out all the solvent. So you drain out all the the mobile phase, and then what you want to do is you're now going to use air to force the the stationary phase out. So you're going to use air. So you can see what I'm going to be doing shortly. Just see. So this is air, as you can see. So I'm going to place the air here. See, can you see? I'm going to place the air, and I'm going to force. Can you see that? So I have succeeded in forcing the stationary phase out. So you can see we have been able to achieve separation. The stationary phase has been unpacked, while the methylene blue and the fluorescein has been separated one from another. Okay, so there are four stages that column chromatography involved. First, we had to pack the column. That's the first thing. We had to pack the column, which you saw, and then we had to load the column with the sample, and then we had to elute the column, or separate the two components. That we call that an elution, and the separation is achieved because of differences in polarities or differences in retention times. And then when we're done eluting the components, the next thing is to unpack the column. So don't forget those four stages. And I want you to place pictures of those four stages in your lab notebook. That's what you're going to use to present your data. First, you show where the column was being packed. You show where the column was being loaded with the sample. And then you show where the elution was occurring. You show where methylene blue was being eluted or separated. And you also show where fluorescein was also being eluted. And then the last thing is to show where the column is being unpacked. So it has been unpacked, and you can see the used stationary phase which was used for the entire experiment. So that's, in a nutshell, is column chromatography. You can see that it's a very, very efficient technique that we use to separate miscible compounds. Miscible compounds. You could have the compounds could be liquid and solid, or liquid, solid. As long as the components will dissolve in a choice solvent, you can be able to achieve separation that way. So I'm going to be talking some more about it, but don't forget the four stages that were involved in this experiment. First, we packed the column with the stationary phase, which is alumina, and then we loaded the column with a sample. And after loading the column with the sample, we eluted the column. In other words, we separated the methylene blue from the fluorescein, and then lastly, we went ahead and we unpacked the column, and this is the used stationary phase that I have in my hand in this beaker. So I'll be talking some more about this, and so that concludes the end of the experiment. Thank you.